Okay, a few abstract examples. Solve for x. This equation, b x transpose plus a inverse equals c. And we'll say all given matrices are invertible. Okay, we'll make that assumption. So just solving for x in the land of matrices. Okay, there's a few things that are different here. So let's just be careful. Just copy to begin with. Okay, let's do like this. Leave a little space here. Okay, what do I want to do? I want to get b or x alone. So I have to get this b away first. So what am I going to do? I'm going to multiply by b inverse. I'm going to multiply both sides by b inverse. But I have to be more specific. I'm going to be multiplying. You see how I'm multiplying this expression on the left. Okay, the b inverse is appearing on the left of this expression. Okay, so I have to do the same thing over here. Okay, you must do that. The b inverse cannot appear there because remember, if you have matrices, E times D is not, there is a difference in general between these two things. Okay, so if I'm multiplying on the left over here, I must do the exact same thing over here. Okay, so that's the main principle I will follow. Okay, whatever I do over here, I have to do the exact same thing over here. Okay, so I get x transpose plus A inverse is B inverse C. I want to isolate for x. So to get this inverse to go away, I'm going to have to invert both sides. And what does that give? X transpose plus A is C inverse B. The order got reversed when I inverted a product. And then I get X transpose is equal to C inverse B minus A. Okay, that one's a familiar operation. And now I will transpose both sides to isolate X. What shall we do here? Oh, this is unpleasant, isn't it? Well, the transpose in this case transpose can distribute like this. And what do I want to do here? Oh, I suppose I could go one more step and get B transpose, and then I'll have C transpose inverted. Okay, because the transpose of a product reverses the product. And also I use the fact that the transpose and the inverse are interchangeable when they appear like this. Okay. Exercise. Find C inverse. A, B, C, A, C is the identity matrix. Okay, same thing. You assume that all the given matrices are invertible and solve for C inverse. So pause, copy, try. Pause, copy, try. Okay, what I would do is I would go A inverse here. So that means A inverse here. So giving BCA is equal to A inverse. Ooh. Then what? So then I would do another A inverse here, A inverse here, giving me BC is equal to A inverse, A inverse. Suppose you could do A inverse squared there, but I'm not going to do that. It's a little bit confusing. So I'm going to get C alone first. And then I'm going to invert both sides, giving me A, B. In this case, I would go A squared B. Okay, let me double check that, see how I did. PCA. Yeah, looks good, looks good. Okay, this step here again, what did I do? I put a B inverse here. So on this side, the B inverse has to appear here. It cannot appear over here. No, no, no. The principle being that whatever you do to one side, you have to do the exact same thing to the other side in order to preserve the equality. And then I, inverted both sides. Okay, reversing the order here, inverting everything. And there's my answer there.